Good evening, all. The purpose of today's meeting is to introduce you to BigSQL and to explain you what you'll need to do for your assignment 3, right? So just pretend that this is today's date, right? So basically, what you'll do for assignment 3 is you're going to develop, just pretend you're a developer, you're going to develop a small database, and your database will have 3 tables in it, right? And you're going to define the specific business problem. Like, let me go over to the next slide and I'll show you what you mean. So, what you'll do is you're going to have the statement of work that describes the specific problems that you're going to solve. You will create your tables, you will insert data, you will write the queries to retrieve the data, and you're going to write a view, right? And then there'll be question and answers. But before we do that, let me explain you. So what is a statement of work? The statement of work describes explicitly what the database needs to do. So let's do an example here. We're going to discuss the small student program, small enrollment program. And I'm going to say that I have a database that's going to track the student performance. And I'm going to have a student. And for each student, I'm going to track the student admission year. I'm going to track the academic program that the student is in, and the gender and number of credits that the student fulfilled toward degree requirements, right? So just suppose that I'm going to be looking at the subset, right? My data is large because I have a lot of students, and I'm going to look at a specific subset. And I have the course, right, which it has the course code, course title, the number of credits, and the duration, how many weeks long it is. And here I'm giving my business rules. I'm saying that each student may have completed none or many courses, and I can say that each course can be completed by 0 or more students. Then I'm going to have another table called enrollment. And an enrollment table will track a record for each. It's gonna track a student in which course the student was enrolled, so to speak. So we have the student ID, we have the course code key, and we have the grade that the student earned, and we have the how many meetings the student could not attend, and enrollment year, enrollment semester. So just conceptually speaking, right? So again, keep in mind this is not a relational database, but we want to sort of like draw, we want to visualize, we want to conceptually understand what problem we are trying to solve. So here, as you may recall from your earlier course, you learned how to do the entity relationship diagram. So this is conceptual. So we have a student, we have a course, and we have an enrollment, right? So here is my parent table student. I have a student key. Now, keep in mind that the constraints are not enforced. In the BigSQL, the constraints are not enforced. So what's going to happen here is that they're conceptual. You would need to watch out to make sure that each student has a unique ID. When you try to insert 2 students with the same ID, the database is not going to stop you, right? It's not going to stop you, but you need to make sure that your data is valid, right? You want to make sure that the data is valid. And now another thing is that if you try to add an enrollment record for a student who does not exist, the database is not going to stop you. But we need to pay attention to that, right? Also, I cannot physically enforce the foreign key. It's all conceptual. Now, when you design your database here, you want to make sure that all your relationships are one-to-many. In other words, if a student can take many courses and a course can be taken by many students, right? I need to have something in the middle where I can have a single enrollment key, and I can, here I'm going to have the course key, and I'm going to have the student key, and here are additional fields. I'm going to track how many times the student was absent. I'm going to track the year and the semester, right? So this is what you're going to do next. So first you're going to define the problem that you want to solve. Then you're going to do this sort of like a conceptual diagram, right? And yeah, I don't want you to think of it as a relational database. It's not a relational database, but it's rather the conceptual understanding. Now, here, even though the primary keys constraints are not enforced, this is something for you to do. You want to make sure that each of your entities has a primary key, right? So each student has a unique ID, and you want the primary key to uniquely identify every single student. Now, you want to make sure the primary key cannot be null, so you cannot have an empty student ID. In other words, you want it to be single numeric attribute, and you want to make sure that the value does not change over time. Like for example, the first name is not a good choice for the primary key. Why? It's because, for instance, there could be more than one Yelena, and I could change my first name at any time, right? It's possible to do the name change. And here, something else to keep in mind for you is that you want it to be security compliant, because if I make my primary key to be the social security number, what's going to happen? In every single table that references student, I'm going to have what? The social security number, right? So then in enrollment table, I'm going to have my social security. This is not good, right? So you want to keep this in mind when you're designing your database for this assignment, right? And some of you might ask me which topic to choose. Choose something that is your hobby or something you're familiar with, right? Now, here it is. This is how the table is actually going to look like in if you after you run the code, I'll show you what I mean. You can look at the table structure, right? But here I'm just trying to illustrate that in my diagram, when I look at this diagram here, every single attribute of every entity will become a column in my table. When I do the create table statements, each of these is going to be the column, right? So here it is, right? So we have three tables: student, course, and enrollment. Does it matter in which order I create those tables? Yes, it does. Also, you're not going to receive an error if you add an enrollment record for a student who does not exist. Conceptually, this is incorrect because we want to make sure that the student in question first exists, right? So we want to populate my students, right? Then we want to populate the courses, and we want to populate the enrollment. Here, there is a little bit of flexibility since a course does not explicitly depend on a student, right? You can do those two in any order. But you cannot do enrollment until you have these two guys here ready, right? So now, let's move on. Now, the order of statement in a script, this is important. First, you want to have the drop table statements. And the reason is, suppose that I'm taking a script and I want to recreate the database. I want to recreate the work. I can have only one table with the same name. What if I already have another table with the same name? Right? My code will error out. I won't be able to create the database. So, at the very top, I want to have the drop table statement. Then I want to create my tables. Then I want to validate if my tables were created as what I expected. Then I want to do the insert statements to add data. And then I want to do, well, it depends on the configuration. Sometimes the database, sometimes it will commit automatically. Sometimes you have to write the commit. So basically what happens is, insert statement does not write to the database directly. It's writing to the buffer, right? And then you write the buffer to the tables. Insert statement validation. So what I mean here is that you want to check the row count. Like for instance, if I insert 10 rows of data, to validate it, I would just check how many rows are in a table, right? So then you're going to write the queries, right? And then you're going to write the statement to create a view, and you're going to run some queries against the view. So I want to point out something else. We drop the tables and then we create the tables, right? So some of you might be asking me, why cannot I just drop the view and create the view? Well, when you create a view, you can use the view to define the permissions, right? Like for example, suppose that I have large table with 100 fields, and I want somebody, like Emmanuel, I want him to have access to only 5 fields. What I'm going to do is I'm going to create a view that pulls 5 fields, and I'm going to grant Emmanuel the permission to access a view. Now, what's going to happen is, if I do create or replace statement, I'm going to change the view definition, but the privilege that I defined to let Emmanuel see the 5 columns, right? It's not going to be deleted. It will still stay. On the other hand, if I drop my view, and then when I create it again, I'll need to define the permissions all over, right? So that's a difference, and you'll see that. So let's continue. So what you're going to do when you write your script, right, which is a big portion of the assignment, you want to put the drop table statement at the top, and the order in which we drop the tables, it matters. Now, we know that there are no foreign keys are not enforced. We know that, right? But still, conceptually, we cannot drop the student, right? We cannot remove the student from university while the student is still enrolled in the course, right? So somehow we have to unenroll the student first and then drop, right? That's what we have to do. In general, the order of drop table statement will be the opposite to the order of create table statement. This is a little secret. So, but now, this is something important. When you run the code for the first time, right, and you may have noticed if you started working on an assignment, when you run it for the first time, the drop table statement will return an error because the table does not exist yet, right? That's a reason. So, okay, here, this is how you validate that the tables exist. This statement, this table, this is metadata. The metadata is a data about the data, and this one syshadoop.hCatalog_tables. So that table tracks. This table is going to track which tables you have on your account. So this is the table schema. In other words, the table schema is your username, right? And this metadata table, it tracks all tables in the system, but I don't want to see all tables. I only want to see my table. So this is my username, right? So that's how I'm checking all tables programmatically. But it would actually make more sense to you when I start showing the hands-on part. But for me to show the hands-on part, let me see. I'm gonna need to find my. I'll find it in a second. My credentials, and I'm going to log into BigSQL. So your task initially you need to create your account, right? And in the walkthrough, you need to follow it, the instructions on how to do that, right? So now I'm going to do the demo, and I'm going to get into the demo cloud. So I'm going to share my screen shortly. Here it is. So I'm going to do login. Okay, I'm going to share my screen. And there is something else I want you guys to be aware of, is that it's highly possible that you might be prompted to enter your password more than once, right? So this is fine. If that happens, keep in mind that Yelena said it happened to her also. Now, let me do this, share my screen, right? So let's just assume that I already created my account, right? So, and my password is, oops, okay. So now I'm gonna type my username, right? This is my database username, and I'm going to enter my password. Oops, uh-oh. And passwords are case sensitive, right? And I'm gonna hit login. Now, I recommend not to select in remember me, okay? This is not good. We don't want the passwords to be cached. So when you logged in successfully, you're going to see this message. This is your username. Now, what I need to do is I need to click on BigSQL Sandbox. And what you're going to do here is that you go to System, and this is what you want. You want to click on here, Launch. Oh, see this? So don't worry about this. This is normal. And here, I'm going to put my password again. I'm going to click OK. Now, this is what we're using. We're using BigSQL. I'm going to click here. I'm going to click Launch. Here, we need to be a little bit patient, right? So this is what not to do. If you start it, if you open up the application, you let it run. You don't hit the X here. Don't do this. Don't exit application by clicking on the next. And another thing that you don't want to do is, if you started running the query, you let it finish. You don't want to stop it, right? So that's not a good, yeah. Because physically, when you stop it, it does not actually stop. It kicks on another process to stop. So now let me do this. Let me put in my password again, right? And I'm gonna do the OK. So now I'm connected to the database. So this is your SQL editor. This is where you're gonna type the queries, right? And I mentioned earlier that you could check what tables you already have. So look, you need to go to the home, right? If you go on home, now here, look, what you want to do is you want to select. So this is home, and you want to select by show. Oh, okay, this is right. So 1 second, that's not home. You want to check the. Okay. I'll figure it out. But I was just trying to show you where you can see all your tables. After table creation, I saw, what was that? Yes, Ayo, this is an excellent question. So after you created a table, the table, yes, what you saw is that you saw the schema name. So the full table name is the schema name, which is your username, followed by dot, and then it's a table name, right? So looks like this is updating something, but we need to be patient because it's updating it for me now. But let's see. I can go to the, nope, that's not what I want. So anyway, let's try to go in and let's start running the queries here. Now, okay, so this is doing an update, but anyway, let's go back here and go to the, see, here is a navigation menu. Oh, here it is, explore the databases. Sorry about that. So when I click Explore Databases, I'll show you what's happening here. Now, here, and you want to look at the Hadoop tables because you're creating the Hadoop tables. Now, here is a list of tables that exist in a system. And what I want to do right now is I want to filter it, and I want to look at my table only. So I'm going to create a rule, and I'm going to say the schema, and the schema is going to contain this, right? Because this is my username, and I'm going to do the filter, and this is going to show me the tables that I have, right? So these are the tables that I have created. And see that this is my course, and this is my enrollment. I still have it here, right? So now what I could do is I can click on it here to see more information here, right? So see this? This here, it's going to show me the table properties, which is the table name, and it's going to show me the schema name, and I can even look up all my columns and more, right? So, and columns, see this, right? It's showing me the column data types. Nullable, it means that if the column can have if the column can have an empty value. Empty value means null, right, in the database. Now here, this is not nullable. It's because when I created the table, I explicitly defined the not null constraint. So not null constraint can be enforced. The primary keys cannot, right? This can. And I'm going to find the script from last semester. I'll find the script. It's in here. Oops. Enrollment.txt. So this is a file that I ran to see the tables that you just saw. Now here, let's look at the script. If you can see at the top, I put my drop table statements, and I have to drop the enrollment table first because I cannot delete the student record if the student is still enrolled in the course, right? Now here what I'm doing is I dropped first, and then here I started working on creating my tables. And I say create Hadoop table, right? Because the table resides on a Hadoop. So this is a keyword. Here I want to say if not exists, right? So if this table does not exist, create it. If the table exists, it's going to ignore the statement, right? But see, that's the thing. What if I want to change it? As you're working on your assignment, you'll be changing it. You'll be adjusting the table structure as you keep on working it, right? So you don't want to ignore it. If I made change to the code, I want it to apply, right? And the only way to apply is I have to drop my table and recreate, right? So what I'm doing here is that I'm saying that the student key cannot be null. So this will be enforced, right? I want to say that every student must have unique key or unique identifier. This is a gender, and a gender data type I'm storing it single character. And here, this is going to be admission year, and the program name, and I make it variable character. And here is the number of credits that the student completed, right? And here I'm creating the primary key, but this is again conceptual, right? So I'm just saying that this column, student key, I'm defining the primary key here. And here, this is called a check constraint, because what I want to happen is that conceptually, I want my gender to be either male or female. And this is just for the storage parameter, right? You want the delimited field, you want it to be top delimited. Each field is stored, right? It's specifying how the data is internally stored. The field is top delimited, right? So here, what I'm doing is I'm creating the course table, again, right? So far we're good. Create table if not exist, student and course. Now the hard part comes. I'm going to create my enrollment table. But the problem is I want to I want to make sure that I do not enroll the student who does not exist, right? So conceptually, just conceptually, I'm going to say I have a foreign key, right, that references a student key in a student table, right? This is conceptual again. So now, each table can have only one primary key, but the table can have more than one foreign key. Because, see this here, I have a foreign key student ID referencing student, and I have a foreign key course ID referencing course, right? So keep that in mind, this is not a relational database, but it's rather a logical view, right? So we are looking at the subset of the student. We are trying to give a structure to an unstructured data, so to speak. So now what I'm doing, I'm here. Well, I just showed you how to preview the table that I already created in my schema, right? But unfortunately, we will not always have a nice interface like this, right? So it always helps, does not hurt, to know how to do this programmatically. So to do this programmatically, you're going to run a query against this table. And I'm going to give you a copy of this code after this class. So here it is. To take a look. Select star from system Hadoop. It's sort of like a system schema, right? And this is a method. This is a method table. It stores information about my tables. And here, table schema equals, and this is my username. So Ayo, in this case, you mentioned earlier you had your username, right? So that's going to be your username. Whatever name you use. Here, it's always going to be in the uppercase. That's how the usernames are stored internally. And this table, it stores the information on the table columns, right? So this is how I check if my table is created as expected. And then here, yes. Oh, your username, yes, that's right. AAK, yes, yes, thank you. Yeah, it's going to be your username. So what I'm saying is that instead of Yelena BY, you're going to type your username in here, right? So you're going to take this code and you're going to change this, right? Oh, I see. I see. So you saw it in the lowercase, right? But the table stores it in the uppercase. This is a table, the catalog table. All usernames in the catalog table are stored in the uppercase, right? Even though it's displayed, like if you look here, right? This is an excellent point, Aya. If you look at it here, it's showing my name here in the lowercase. But internally, in the database, it will be stored in the uppercase. So if I go here, if I go to my, let me go to my editor, and let me run this statement programmatically, right? So let me go back here, and I copy this. So you'll see this, it's gonna run, it's internally usernames are stored in the uppercase. Even though it's displaying it in the lowercase. See this? I'm going to run it now. So here, see this? It means it's running and it's finished now. So take a look at this. This is in a uppercase. So now let me take a look. Let me take a look. Your username, right? So I'm going to take this and I'm going to put another username, right? So this is one of your classmates. And I'm going to run this, right? And it's going to show me what tables your classmate has, right? So this is her username, and those are her tables. So, well, yes, Ayo, this is an excellent question, but This is a Hive schema. See this? This is a Hive schema. Your username matches your Hive schema, but this is a table schema. See, this is a little bit different. Your username is the name of the Hive schema, but this is the actual table schema. See this? So if you want to use your actual username in a lowercase, you would have to query for the Hive schema. But here I decided to query for the table schema instead. See, there are two fields, right? And the same thing here, the table name, and this is a corresponding Hive table name. It's going to be in the lowercase. But this is, see this? So if you're querying for the Hive table, then you're going to put the lowercase. Now, suppose that I don't know her user ID exactly. So what I could do is, I could do this. Where, and in here I'm going to put like. Okay, this is what I'll do. So like, and then here, what I'm saying is that it starts with these 4 characters, and at the end it could have any number of any character. I'm gonna just go around, right? There we go. Yep. So just giving me all users who have a similar user ID. This is 4 starting letters, and this is it means any number of any characters, right? So if you can query for the Hive schema, or you can do this for the tab schema. So you can do it either way. Thank you, but it wasn't very good, and it wasn't actually an excellent question. Now here I'm just showing you how to insert. There is more than one way to do it, but the way I like to do it is that I like to list all my fields, and underneath I like to list all my values. You might be thinking, where do I get the data? Well, you can make it up. I'm not gonna, well, the data has to make sense, right? But I'm not going to go ahead and check if the address you enter is in fact a valid address. I'm not gonna do that, but you want to make something that makes sense. So here I made up. I have several students who are enrolled in different programs like database systems, data analytics. Now, notice that I'm not storing names in here because I don't want to store any data that reveals person's identity. I want to run my analysis about the person, but without actually knowing who the person is, right? So here I'm doing the course, I'm doing insert statements against the course, and then I'm doing enrollment, right? So after that, well, I put commit, and here I'm just showing examples of some queries. I want to see the average grade, right? So remember that the select, and then here after the select clause, I put which fields I want to select, and this is the grouping function. I want to select the average grade, assuming my grades are numeric. And this is a table name, and here is a grouping field, right? So I'm going to do the group by student key. And same thing here, but here I have another condition. I want to display only the student who have an average grade above 90. Now, see, here, remember the difference between where clause and a having clause. If I wanted to exclude, if I wanted to find the average grade, but exclude all grades below 90 as part of my average calculation, then I would put the condition in the where clause, where grade is greater than 90. Here, I want to exclude the students who don't meet this condition, so that's why it's in a having clause, right? Here, what I'm doing is that I have a enrollment and I have a course, right? And what I'm trying to do here, I want to see the average course grade and the number of students enrolled in the course. This is what I'm doing in here, right? So now here, this here shows you an example of the join. It's a three-table join. I want to get this information. I want to see the student key. I want to see the academic program the student is enrolled in. And here I want to see the course code, course title, and I want to see the grade. So to do that, you would need to check in which tables you have the required information, right? So you have to check which table stores the information that you need. And then one way to do that is that you can underline, right? So once you have the table structure, you can underline the columns that the tables have in common, right? And that's a field that you use to join. Like if I look even here on my create table statement, I see that my student has a student key and my enrollment has a student key, right? This is a field that these two tables have in common. So I have to join my student with enrollment, right? If I have to pull the student key in the student information academic program and the grades, then I have to do the join. Plus, if I want to pull the course information, I have to join my other table here, right? But sometimes what happens if I give you 10 queries to write, and each query involves pulling data from 3 tables. Would you feel like writing this join in every single query? Probably not, right? There is an alternative way to do this. I can create a view, right? And the view will pull the data from 3 tables, right? I'm defining the table join inside a view. And then instead of writing the join in every single query against my 3 tables, I can just do the select statement against the view, right? Now the subqueries, and I have to show you that. So here I want to list the students who earned the grade in the course above the class average, right? So here I want to list the student who earned the grade above the class average. I have the table, that's a view rather, academics, right? And the view is tracking the student key, the student program, course code, course title, and the grade, right? So how do I know who earned the grade above the course average? To start with, I need to find out the average, right? I need to get my average. And the average has to be for the course. So this is called the correlated subquery, where I'm taking the course code from the outer query and I'm passing it here. Okay? I'm selecting the average grade per course, and if the student's grade is equal to or above this average for the course in question, the student will be returned. Otherwise, the student will not be returned, right? So this is an example of the subquery. So now let's go ahead and see if we run this code, because I did not show you how to run it. Now, after this lesson, I'm going to give you this code as another example. When you try to run it, you'll be creating this table on your schema, on your username, right? So I won't be able to access your table and you won't be able to access my table. So don't worry about creating a table with the same name, because you are working on your account while I'm working on my account, right? So let me delete this and let me run this. Now notice that you have this in a brown, right? This is a color code for the reserved words. So now let's do this. Let me go ahead and run this. I'm gonna hit run, and it's supposed to run everything. Succeeded. Well, sometimes we have to be a little bit patient. And another thing, I'm gonna warn you about it. I'm gonna be honest. Do not mix the create table statements with insert statements. Do not do this because it could lead to unexpected results. Trust me, it could lead to unexpected results, including creating the table logs. We don't want this. Something else to be aware of, and I keep on telling it every single semester, and somebody still does it. Do not use Microsoft Word or any Microsoft products to type your code in. They introduce the characters that are very hard to fix. Quote is one example, but there are more. And some of the characters you cannot see. And at times, the only way to fix it is to basically redo the whole code. And this is sad, right? So now I run this, I created my tables, and at the moment, my tables are not going to have any data, right? So what I need to do is I need to run my insert statement. So I'm going back to my code. Yes. Do I need to clear the editor? No, you don't. No, you don't. You don't need to clear the editor. Excellent point. No. But the problem is how you run it. So if I did not clear this editor, right? Suppose that I did not clear, and now I'm gonna put something here, put more code. You want to make sure, oops, Jesus, you cannot do this. You would have to select the code that you want to run. So let's see, let me try doing it. Let's see if that works. Because when I click run, it usually runs everything that I have in my editor. But I believe there is an option that you can choose where you can run only. See that there is an option here, Aya. Right now, it's gonna run all statements that I have in my editor. I can choose to run the statements only from the starting location, yes. But ultimately, the code that you submit for your assignment has to run as a script because we don't debug the problems one line at a time. So an instructor grading your work should be able to copy and paste the code to his account and run it, right? An instructor grading your work should be able to reproduce the database on his account. This is, yeah. So let me see, let me go to the code again. Here's my code, right? So let me put everything actually now. Control A, Control C. And I'm going to run everything. Control A, delete, Control E, let's see. Here we go. Right, so now I'm gonna run everything. This is what you're eventually gonna do is we want to make sure that when you put everything that it works. Another thing that I'm missing here is that you want to put comments in the code. And a comment is a non-executable line of the code, and it basically describes what the code does. Okay? And in SQL, there are two types of comment. There is a single line comment, or you can have a block comments, right? When you comment more than one line. So now let's go ahead and run this. And based on my settings, I'm going to run everything in this editor. I'm going to hit run. So now suppose that I did something that I don't want to do it. Well, don't stop it, just let it run, right? You want to let it finish. So here it is, and you're going to be able to see the status. Okay, it said succeeded. Yeah, but did I copy everything? I think I did. Yeah. It's because here I only have like 5 insert statements per table. In reality, that's not what you're going to do. In reality, you're going to do the load. Are you going to have the loader where you read the file into the table? But for the purpose of this exercise, this assignment, you just do insert statements. So here it is. So this is a statement that I ran, and the statement is succeeded. If the code fails, you're going to see the error. It's going to be like a red X. And you want to look at the error message, because sometimes the error message can tell you a lot, right? It can tell you a lot. So now here I've got my tables, and here I run my queries. This is a SQL statement. So here is the data. I can click on my data, open, and this is a report that gets generated. All right, so this is my report. here it is. So that's the data that was imported, and I can export it as a CSV. Or I can alternatively I can just click here and see the output. Right? I can click here and see the output. And I can also control the number of rows that I can see per page. Right? Now, suppose that my output is too large, I can further define a filter on it. But something to keep in mind is that if I define filter here, it won't be added to my query. If I want to rerun it to reproduce this result, right? Suppose that I add a filter, not programmatically, but here, if I want to reproduce the result, I would have to re-add it again. So I recommend doing all query edits programmatically. Just assume that you don't have this interface. And something else to keep in mind, this nice interface here, filters, it might not work in some of the browsers. It does not work in a Microsoft Edge browser for me. All right. So let me do cancel. Now here you also can learn more. You can click on learn more to learn about the SQL statements, and you can do the, well, explain. This probably won't work, but in general, explain will tell you the query execution plan. So in which order the statements are executed, and sometimes it can tell you if the query is written effectively. Like, for example, suppose that I want to pull data from student and enrollment, and I meet the joint condition. The query plan would show me the full table scan, something like that. Right? So sometimes if my query takes forever to run, sometimes I want to see the execution plan. I won't get into it in details, but this is something that you would have covered in details if you were taking the database program course, right? So syntax assistant, I have not even, oh, this part here, don't count on it. Don't count on it. It won't be there for you every time you like. But here, in general, what it allows you to do is you can select the table that you like, and then you select the columns, and it's going to build the query for you. But, well, there is a problem with this. And the problem is that there is no way to do the joins, right? I cannot add anything that's more complicated. For instance, such as functions. I cannot take the substrings. And this is not going to work in all browsers. So I would strongly recommend that you write your queries. Do not rely on the tools to do that for you. All right? And here, basically, I just ran these statements here, right? So far so good, right? So now what I'm gonna do, I'm going to try something. I'm just gonna try it. And the database, it may or may not let me do this, but Elena is going to be really nice right now. So we have an enrollment table, and I'm going to just update everybody's grade. So I'm gonna do this. I'm gonna try this. I'm gonna say this update. I'm gonna do update enrollment set grade equals 100. So now Elena will try to give everybody in a class a grade of 100. Will the system let me do this? Who knows? Let's see. So now I'm gonna also answer Aya's question. If I click run, it's gonna run everything here, right? So, but I don't want to do this. I want to run only from the current location, so I temporarily switched it. And I'm gonna hit run. Let's see what happens. Failed. Why does it fail? This is your homework. Do the update statements work here on Hadoop? Do the delete statements work on Hadoop? Well, this is your homework, right? That question on the homework is on purpose, right? So these insert statements, they worked, right? But update statements and delete will not work. Well, you can drop the whole table, but you cannot just go in and delete, right? I cannot say delete from enrollment where grade less than 90. It won't let me, right? Yeah. So yeah, Patrick, do you have anything to add, or did you find it?
No, Elena, all you say were great. Yes, nothing specific to
Okay, but but I mean, another thing that yeah, people usually ask about this assignment is that well, it does looks like you're working with structured data, but well, basically this is extracting the structure from unstructured data. But in your assignment, you are asked to compare the unstructured data with semi-structured and structured. Basically, well, we cannot look at the course topics in isolation, right? So that's basically you comparing the data that you looked at last assignment, where you had text, right? And you looked at the assignment. You had first assignment, you analyzed the text. Then you had another assignment where you analyze the metadata about the text, right? And here you're looking at the actual sort of like tabular representation, right? So when you extracted the structure, it can be represented as a set of tables, where when we looked at the text, it's very difficult to represent it as a table, where, of course, you can use a sort of like a bag of words approach to see how many times each word occurs, but do we have a predefined set of words? If we want to represent it in a tabular format, do we know ahead of time which words we're gonna have? We don't, right? So it's more like a dynamic. It's harder to extract the structure, right? So that's something for you to think about it, and something for you to explain in your paper. And you want to always provide examples, right? So that's basically what the reason for this question is, because we don't want to look at things in isolation. We want to kind of apply what we learned before to what we're learning now, right? We don't want to see these topics. We don't want you to see each topic in isolation. We want to see the big picture, right? And if you need help with ideas for your project, I will go in and read your course introduction to see something that might be your hobby, right? Something that you know well about. It could be, it's not necessarily have to be the academic database. It could be something that you might be collecting. For example, you're collecting stamps, right? So you can do something on stamps. Or if some of you like to track the exercise program, right? So that's a good question. That's a good topic too. But you want to come up with three tables, and you want to make sure that there is some type of relationship, right? And you want to define where you store each properties. Like, for example, the academic major is a property of a student. It's not going to be stored with enrollment. It's going to be stored with a student, right? Same thing, course title. Course title will be stored in a course table, where enrollment table is going to track, it's going to store the course ID. Another reason is if I rename the course. What if I rename my course? I have to rename it only once, okay? Sometimes a class might change name. Then I'm going to go to the course table and I'm going to just rename it there in one location. So now let me see. I think I have questions. So let me see. Okay. Do I need to? Okay, I answered about the clearing the screen. What is the minimum number of rows required? Does it say 5 to 10 in the assignment requirement? I'll need to check. Does it say 5 to 10 in each table? Yes, and do that. Do exactly what is required. If it says 5 to 10, then it has to be 5 to 10. And the reason you want to try to have at least 5 variables, 5 fields in each table, is because when you write your queries, you want each query have a purpose and a meaning, right? So that's one reason you want to make sure that you have enough fields. The data does not have to be like real data. Like for instance, if you're tracking data about the books, I'm not gonna go to the bookstore and check if the price is correct, but it has to be something that makes sense, right? So let's see what other questions we have. Any other questions? If there are no questions, then Elena starts asking questions. How many primary keys can the table have? Well, I realize that it's not enforced. The constraints are not explicitly enforced, but how many primary keys can the table have? The primary key can be only one, right? Only one, excellent, yes. But the foreign keys can be none, or it can be as many as I want, right? Because none, for example, course table does not have a foreign key. But on the enrollment table, it has two foreign keys. One is referencing course, and another is referencing student, right? And I would strongly recommend everybody to start working on the assignments as soon as possible. And also keep in mind that this course has two TAs for a reason. You want to ask for help. Do you say that we are going to load data? No, you will use insert statements, Linda. For the purpose of this assignment, you're going to use insert statements. But in a work environment, if you were doing it in a work environment, you would populate the data through connectors. There is something called connector. It's a program that's used to load data from one application to another or from a flat file into an application. But for the purpose of this assignment, we're going to do insert statements. That works well. In general, insert statement on Hadoop is not a good idea, right? And you'll find it in your readings. So that's something to note in your study limitations. Insert statements, yes. Oh, I'm glad I clarified it. Linda, let me know if it clarifies. But I'm saying that in here, for the purpose of this assignment, you're going to be doing insert statements. But in real life, when you're doing it in a business setting, right, you're going to have a connector or a loader to populate the data, right? But here is just few rows. Yeah. So, any other questions? This is your opportunity. But I want to make sure that everybody is all set, so that I want to make sure that everybody has an idea of what is expected from the next assignment, right? Yes, Patrick and Linus, let me know if there's anything you would like to add to this.
No, I think you covered it all, Yelena. Nothing to add. Thank you.
And Patrick?
No, I'm good. I just, like you said, I want the students to start early so they don't wait the last minute to try to watch the assignment, because sometimes they it show that they can make more mistakes and also provide not a great analysis when they start late. So if they can start right away after this WebEx based on the information you provide, that will be better for them to start right now. And if they have question, email me. I can help them either with the data, with the analysis, but don't wait last minute because the longer you wait, the less time you will have to ask questions and to provide a great analysis of your data.
Right. That's true. And another thing I noticed happen is that this is a sad experience when a student was waiting until the last minute, and then there was a mistake, copy and paste into Word, the whole code got corrupted, and it was really sad. And it happened on the night when assignment is due, and I was sitting to see what we can do to recover, and basically you really cannot, you have to retype. So do not use Word for the SQL, never, ever. And avoid using Word for the R code as well. It's not recommended. Right? Well, someone always does it, but yeah. So anything else? Let's see if I stop sharing my screen. I want to check everything in the slides just to make sure that I covered. So this is showing you how to check the tables, what tables I have programmatically. And here it's just showing me that I can go in and I can just filter. I can just filter out like this, right? But, you know, you want to know how to do it programmatically. And here are some insert statement key points that I just basically described. But since there is no, the constraints are not enforced, so you want to watch out in which order you insert in the data, and you want to make sure that in your insert statement you have a correct spelling, because if the table name is misspelled, you're gonna get an error. It will the code is going to return you an error message. The character value should be enclosed in quotes, like for example, where name equals Yelena, Yelena should be in a quote. Now, here, another thing about an insert statement is that, as you may notice, insert statements with the names and the values, you want the order to match, right? Like if you see this, share my screen, if you see this again, here, see this? These are the insert statements. You want to make sure, see this is the order: student key, gender, admission year, academic program, credits completed, right? So this first value is going to go into student key, this is going to gender, this is going to go to the admission year, this is a program, and this is the number of credits completed, right? So that's what I meant by the order. And we have to pay attention to the data type, because if something is numeric, I cannot insert my character in here. So honestly, from experience, the insert statements happen to be the most challenging part of this type of assignments. Insert statements happen to be the most challenging. Okay, so just something to be aware of. And here I'm just showing you an example, right? So here it is. See this? If you look at the table structure that I was showing you, this is a list of columns, and I put them here. And this is a list of data values. And then I'm saying student key must be an integer, right? And so it has to be a number. And we need to remember that we have to use unique numbers, right? Gender must be a single character value. And as you may remember, I defined the business rule. It has to be uppercase M or uppercase F. The rule might not be enforced, it might be conceptual, but I want to keep my data valid. I want to pay attention, right? And here, oh yeah, for the views, it's just showing you here how to check the properties of a view. And it's good that I'm looking at the slides, because I need to make sure that I'm showing you everything that you may need to be doing in your assignment. So see this is here, administer, explore database, and here, if I scroll down, let me see, I need to make sure that I'm still Yes, I'm here. I'm still under my, so I'm going to the Database Explorer, right? So this is me, and I need to find my view, right? So I believe, what did I call it? Let me go back to my code here. This is my code, and if I scroll down to the bottom, here it is, create to replace view, academics, right? So I need to look at the academics. Now I'm going back here, and I'll have to find it. But anyway, oh, here it is. I'm sorry, my fault, guys. I have to go to views, and now, well, I can try sorting this, but again, if I do sort this, I'm gonna see the work that was done not only by me. So I have to kind of like rely on filters, and I'm gonna say rule, and I can say, let's do name contains academics filter. Here it is. This is my view. Now take a look at this. I'm gonna click on this. I'll show you the properties. Uh, Here, this is a schema name, right? So this is my view, and I'm an owner, and here it's showing me when it was created and when it was altered. Now here I can see this. If I say open in SQL editor, it's gonna open the code. It's gonna show me the code that I used to run this, to create this view. The code to create a view is actually stored in the database. So that's something for you to keep in mind. I can just go in here and I can pull my code, right? Okay, let me close this out. And here I can see the columns information, dependencies. This is very important. This shows me the tables that are used in a view join, right? In a join to obtain the view. If I delete any of these tables, right? If I drop any of these tables, my view will become invalid. So this is a little downside. If I remove the table, the view is going to be invalid, right? So this is for you something to remember. And if I created a privilege mentioned earlier to allow Emmanuel access to this view, it's going to be listed here. Right now, there is nothing here because I did not explicitly give anybody permission to see my view. But if I do that, it's going to be listed. Oh, okay. Looks like I don't have the privilege to do that. But anyhow, if I had the privilege to give somebody the permission, it would show. If I had the privilege to give somebody permission, if I grant the permission, it would show in the privileges, right? So columns, as a columns in the view definition, dependencies shows me the tables in the view definition, right? Sometimes I have to know it, because if I want to drop my table, sometimes I want to check if there is a view in the system that is using the table, right? And if there is one, my view is going to be invalid. Now, what I want you to think about is that also using the view, we are reusing the code, right? Code reuse. I will need to repeat the same join more than once. But what happens if I have a view that pulls from a view, and then another layer of a view pulling from a view? Is there is an impact on system performance? So that's something for you to think about, right? So now let me stop sharing for a minute again. Now let's go back here. So that's a view properties. And here I'm just showing you again how to do the subquery. So this is an example. I want to see the student who received the grade equal to above the course average. So my first question is, what is the course average, right? But I don't want just the average for overall courses. I want to see the average for a specific course in question. So this is called the correlated subquery, where you take the field from the outer query and you put it inside in here, right? So you want to say the course in question from this academics view is the same as the course from the outer query. Yeah. So here I just put a link for you where you can find some additional example. Okay. Right. So let's go here, and this is a troubleshooting. So if you get this error message, it means that new session timeout. Like, okay, you started working on your assignment, and then your friend calls you, and you spent half an hour on the phone. Just an example. When you come back to do your work, you're trying to run a query, and you're gonna get the credential error. Why? Because the session times out. This is done for security reasons. I'm not quite sure about the settings here, but in general, the federal government has a 15-minute setting. So if you're not running any code for 15 minutes, you're going to be logged out automatically. You might not see the another login prompt, but you're going to see this error. So I guess the best thing to do is to log back in, and it will fix this error. Here is another example of an error. It's because you want to select the BigSQL database. Right? You saw the drop down, you want to select the BigSQL. And I guess that was it. Another opportunity to ask questions. Questions? If there are no questions, Helena will ask questions. Now, remember which two parts of the query must have, right? Select and from, right? Your select statements must have select and from. I think some of you may have missed it on the DB quiz, yeah. Right? So we have what? Select and from must be there. Where clause filters the rows. Group by allows grouping. Order by allows sorting, and having allows filtering out the groups. It's not a single row, it eliminates the group. Right? So my understanding is that everybody is well prepared to work on assignment 3, and everybody will submit the work on time, right? Can we do it? Right? Everybody will submit the work on time, and it's going to be top quality work. Right? So now it's a good time to ask for questions. Questions? So I went through the slides just to make sure that I covered everything important. And I guess that's all if you don't have questions. But a question and answer session does not end at this moment. You can post your other questions in a discussion. Post your questions in the discussion. Okay, does it imply that Hadoop uses regular SQL? Well, no, it doesn't. It's not regular SQL, but the syntax is the same. Emmanuel, the syntax is the same. But what's not the same is how the query gets executed internally. But the syntax is very close. So the syntax you use for DB is the syntax here, but there are some exceptions. I demonstrated that I cannot do updates. It's not because I wanted to update everybody's grade to 100 and TA does not have privilege to grade. No, the reason is because you cannot just do an update statement. And you'll find it more in the reason. I mean, in readings, sorry. But and the SQL looks like the same, but internally the execution might be different. But create table statement is different. You saw the difference, right? I said create Hadoop table. And the data is stored in a different format. Yeah. Anyone else? But that was excellent question, Emmanuel. I like the question. So, and I hope I answered Linda's earlier question. I want to make sure that everybody's questions are answered. All right. How is execution? I think, Patrick, I think it might be better to answer this question. The question is, how is the execution of the SQL statements differ from regular queries? Because, well,
You mean BigSQL or
yes. Because Emmanuel, he pointed out that the queries look the same, right? The syntax is the same, but but internally it's different because it's rather distributed, right?
Yeah, and for BigSQL, there's some addendum you have to add to your function compared to normal SQL. You don't have to add specific if the big data or if it's the normal data. That's the difference. So the function are the same, but when you're doing BigSQL, sometimes you have to specify if you're using a big SQL statement compared to if it's normal SQL.
Yeah. But the idea is, but some good news, there is no R in this assignment. Bad news, there is no R in this assignment. Right? Well, any other questions? Oh, Amiga, may I ask you to speak up to say what was your question? Amiga, I want to make sure your question is answered. Should I unmute you? Amiga, go ahead, speak. What is the question?
Oh, what I was saying was that, when the execution happens,
Mm-hmm.
in the SQL, I think it starts from, from or ordered by or something, and then it goes down. So I was wondering how different is with the Hadoop, like the way the execution happens. Does it start from select? Does it start from having? I don't think there's going to be having, right? But there's where. So
Well,
I was just looking at the execution plan just to see like where does it start?
well, you have to first get to the table that you want to select from, right?
Yes.
And the data is distributed.
So which means that it starts from select. Is that what you're saying? The execution happens
From.
from. Okay. So it's basically the same with the SQL server.
But the data is distributed here. Here the data is stored in a cluster and it can be distributed among several clusters.
Sure. That's why. So I guess that's why it's going to be different. So
yes.
the ranking might be different than the regular SQL.
Yeah.
Okay.
Patrick, did I answer the question correctly?
Yes.
Yes, thanks.
Yeah. Well, conceptually, if you're familiar with SQL, then you should be able to apply it. Yeah.
Yes.
So you're not learning a brand new language, so to speak.
Yeah, it's not a brand new language. You're right. But as you say, since this is a distributed database, I guess the way the execution it might be a little bit different than the regular SQL.
Yes.
The relational database.
Yes. Yeah, that's a distributed. That's right.
Sure. So what makes it different being the distributed? Because isn't it initially Google was a distributed database?
Well, because it has to pull the data from multiple partitions. It has to pull the data from multiple clusters. That's an extra step.
Okay. All right, thanks.
Okay. So I guess it's about 9:30. So when you have additional questions, please go ahead and post them in the discussion. Okay? Okay. Everybody good?
Yes.
So, thank you for joining it. I'm gonna stop the recording. Where is it?
Thanks, Elena. It's a good session.
Sure. Thank you.
Thank you, Elena.
Thank you. Thank you, Elena. Have a good evening.
Thank you.
Okay. Good night, everyone.
Right.
Yeah.
Good night.
Yeah.